Hi, welcome back to my channel. Hope you are all doing good. Today I'm going to talk about Docker service. What is Docker service? How do we leverage the Docker service? What are the components of Docker service and architecture of the Docker service and so forth. Okay, so let's understand some of the basic concepts. So basically, Docker is a containerized platform service which is enabling to optimize the cost on the infrastructure side. That is the beautiful thing which we can get it from the Docker service. And the second thing is it is quick way you can develop your application and you can host it onto the respective deployment environments like development, staging, or quality assurance, or production environments. So that is how today this particular service is so much popular. So let us understand some bytes of the Docker instance. Okay. So Docker is an open platform for developing, shipping, and running applications on the Docker platform. Okay. So that means you are developing an application independently. That is what the second point is talking about. You are going to host your application onto the real environment that is running a Docker service, which is a infrastructure service which is running. You can bind your application with a Docker image and then you deliver it. So your application development is different, Docker service is different. To build these two and host this as a image. This image can vary depends on your use cases. Say application started developing and say productionizing. Before productionizing, we will have the dev environment, stage environment, and production environment. So you wanted to first move to the dev stage and then production. So what we are going to do is we are creating the first release, say 1.0 with my application, and then I would say 1.1 the next release, 1.3 then further release, and so forth. So every release you wanted to manage and maintain the applications. So you will create an image and that image will have the versioning and then and so forth. You store that image and then you use that image to run the container onto the real deployment infrastructure. Okay, so that is what it is all about talking. If you want a self-explanatory points, Docker enables you to separate your applications from your infrastructure, so you can deliver software quickly. With the Docker, you can manage infrastructure in the same ways which you manage with your all applications. In the earlier days, we had to procure like a infrastructure to host your applications. That is a little bit complex. Still, we need to follow that, but here Docker enables you to optimize the cost of your infrastructure. In the same host, you configure the Docker service which will enable to host as many as applications without much infrastructure procurement. That is the advantage. Okay. So Docker follows some ground rules. We supposed to follow that. So configuration files and all. Docker and Docker Compose. There are a couple of things which also we need to understand. Docker is basically a daemon service which is running wherever the host which you are going to install it. That will give you flexibility of getting the image, creating a new image, building a tag, or keeping safe of your image, that is using a Docker push commands. The push command is expecting a Docker registry wherein you can safely keep your images based on the versioning which I described before. And Docker follows a configuration file for customizing the Docker's image. And Docker Compose is not providing the same capability of like a Docker. So this is used to create a service. If your service is depending on another service, you can easily establish. That is the beautiful thing which will be supporting by the Docker Compose. This Docker Compose is used to only pull the things and start the service. It is never going to create a new image, build a new image, or push a new image. That's a very much keen to aware the difference between these two. Without that, it will be bit challenge. So Docker can do all. Docker Compose can do only one thing. Start the service. Look for the dependency service if you want. You can customize it, and then you can start the services. That's all. Okay. So why Docker is needed? It is fast, consistent delivery of your application. As I said, you can have the locally installed Docker, and then you can build your application. You can create the image. You can test it, ensure that your application is working. You really don't need to really go to the real environment to test. If there is anything failed over there, then again come back to the development environment. It's a big round trip where you can avoid time and cost of these things doing it. That's the advantage. And responsive deployment and scaling. Responsive deployment means Docker image usually it is less than some G less than some MBs, sorry, not GBs, so that it can start very fast during the deployment. And if you want many instances of your application, you can also do the scaling. That is also flexible to do it. That is what this is. Running more workloads on the same hardware. So you don't need to separately procure more hardwares. So use the existing hardware, host the Docker service, and then start launching as many as applications. The applications can vary either C#, Java, Node.js, whatever you can call it as. Ensure that the required dependencies are installed and configured in the baseline Docker container image. That is very much important. So that will take care by some experts to create that images. Developers can start using those images from the registry. Okay. So we will understand the Docker components or Docker objects, whatever you can call it as. So in the Docker, you will see Docker images, Docker containers, Docker networks, volumes, plugins, and other objects. Images means, as I said, you have one small operating system running in that image, configured required softwares that you can use it, and you can bind your application with Docker image by following the some ground principles of the Docker instructions. And once that image is ready and available, you can run that image, and that it is called as a container. The container exposes the service ports which can be accessed by the application. Okay, so that you can host it either Java service, C# service, or whatever service you want. If you want to create network, you can create it. Volumes means you can bind your image to talk to any of the disks which you configure external, like NFS, NAS. You can mount the disks and map with the Docker so that all the things will be getting stored in that disk. So Docker registries. Docker registry is a it is a container registry wherein it holds all the images which you are creating. As I said, as per the application, you create version 1.0, 1.1, 1.2, and so forth. All these images required every release if you are deploying it, right? To keep safely in the registry. So you can have the Docker registries customized according to organizations. They provide that software separately. So the Docker registries are two types. One is a public registry, one is a private registry. Private registry, which is bound to that limited environment. Public registry, anybody can go ahead and use it. For example, hub.docker.com. I'll give you the reference links. And if you want to test the Docker, you can definitely install using Docker software, which is freely available. No cost for the individuals or developers at home use. Not in the organization. In organization, they ask for the support charges. And as I said already, Docker Compose, it is another binary where you need to separately download and install. This is only used to pull the images and create a service on that pulled image. Sorry about it. Okay. So this is the Docker architecture. If you see it, there are three major components involved: client, Docker host, registry. Let us talk about the first registry. Registry is basically a software which Docker is supporting. People has to use and customize according to their organization needs, where they can store all the images. For example, Nginx, this is a web server engine. Ubuntu, say there is an image which is available to download any of the Ubuntu Linux based image. Yes, you can. And you can see that Postgre, yes, there are ready-made images available which we can use it. And extensions, if you want to integrate with like a Bitbucket or with the other kind of a sourcing tools, extensions, you can definitely do it. And you have plugins. Say that you wanted to have Docker image statistics to be configured in a Grafana, you can do that plugin. And security plugins you want to configure, yes, you can go ahead and configure. These are the more benefits which will give, because registry is the major component which will be storing all of our images. The images should not be corrupted or uh, created with any viruses and all, right? That's the reason this service is highly protectable within the org or outside the org, so that images are safe to run our applications. And you basically run a Docker desktop, for example, development environment. In the real environment, they use Linux based fundamentals to download and install and configure. In development, you can use the Docker's desktop environment. Okay. So once you install the Docker desktop on your Windows machine or Mac machine or Linux machine, it runs one behind. There is a process called Docker daemon. This Docker daemon is responsible to communicate between registry and client. So along with that installation, it comes with the client command, the client softwares also. Okay. So whenever you do a Docker pull operation, here they have depicted only three. There are many things which you can do it. You can go ahead and research it. So whenever you pull a specific image, I'll show you the pulling process. And what happens, it communicates with the Docker's daemon. Docker's daemon goes and checks in the public repository, or which repository name which you configure, depends on that. It goes and checks that particular image is available. If yes, okay, this image was available, pulls it and stores into the Docker's host where it installed it locally. And then what happens, you apply a Docker run command. This is going to start the container on that particular image, whatever image which you requested, and then comes up and running the service, which exposes the ports. If you have a service kind of a port based exposure, it starts running. You can connect with that port and you can perform based on your operations. Okay, that's how this Docker host basically bridges between client and registry. So your application you are hosting in the Docker, it is all working as expected. Now you wanted to make a new image by combining your application code with the Docker's existing image. So you need to follow the Docker build commands, and you can tag versions, say 1.0, 1.1, 1.2, as I said, like that you can do versioning. And then you can use the Docker push command. What happens, you will get that instruction, Docker's daemon, and then it pushes that image into the repository, the registry, I mean, say it goes and resides, so that everybody can start consuming the same image, so that deployment and development is. So by default, Docker comes up with a configuration file called Docker file. This is exact name they used it. So here there are certain instructions which I have configured. So this can have variant of the syntaxes with different attributes, instructions. Please try to refer the Docker software for more details. So here what I'm doing is the highlighted portion from, I'm specifying from, is an instruction set. It is saying that openjdk colon 19 alpine. Alpine is the Linux image. It is used to build this image, OpenJDK. This is the name of the Docker image which they publicly hosted. I'm going to consume that. Okay. So this is a OpenJDK-19. 19 is the version of the Java version, and Alpine is the Linux which used to create that JDK. So I'm going to use it, and I'm customizing that image as per my needs, and I'm specifying that maintainer. Now onwards, whatever I'm going to reuse this image, I'm going to maintain. This is like a documentation, and if I want to run any Linux based thing, software dependency, yes, I can run it like this. Now I'm initially checking that whether I am having that JDK version or not, making sure that, and I'm creating an environment variable, and then that variable I'm creating a directory in this particular image. Okay, that will go ahead and create, and then after creating, I'm copying a particular jar. So this is the jar which I have created. You can see in the reference links. I'm going to demonstrate that. And where to copy to this directory, I'm specifying copy my jar to this directory, and then I'm making sure that that directory is my working directory according to the Docker image which holds. Okay, and then I'm giving a startup of the application during Docker run command which I issue. So I'm giving an entry point for this. So likewise, you can see a lot of instruction set. Please try to understand it. Java-jar, this is the jar where available in this working directory. It starts running. Likewise, every version you can use, say next time if you want to build it, you can build it with 002 likewise. So as I was telling you, Docker Compose is only used to pull the container image and start the service, or start a service which is depending on another service. For example, here I am going to start a Kafka broker service, but Kafka broker essentially required a zookeeper service. Okay, so I wanted to start both, depends on my application needs, right? So if I want to start two services separately, yes, I can go with the Docker based. But if I'm going with the Docker Compose, I can start it. You can see the instruction set. Version 3 services, zookeeper is one of the service name, and container name is also zookeeper, and this is the environment. Where is the image? I'm pulling the image from Confluent Inc. This is how they specified. This is the version which they are supporting. And I have another service broker that is also Confluent Kafka, and 701 is the version. And the container name which I'm specifying as a broker, I'm specifying that the service is going to expose. This is the internal port, this is the external port. The same way here this is the internal port which is going to use it, and external port. Okay, and now I'm specifying that my broker service is depending on zookeeper service. So it is easy. Now I don't need to issue two separate commands to start two different services. That is the beautiful thing with the Docker Compose. Now I'm specifying environment variables according to the Confluent Kafka which they designed this image. Okay, so this is a sample example which I'm giving it to you. This is a perfectly working example. I have already tested it. You can please try it. So now we will try to understand a Docker service, how to create a Docker image, tag it, and push it. So before you push it, you need to register with the hub.docker.com or create your account in that. There you will see public repository registry type or private registry. You can specify those instructions that I'm not going to give you here. I'm installing Java 18, Maven 3x, Docker community, Git. All these are available. And for example, say that I'm going to check out my source code, which is a Spring Boot based application, which is already stored in the GitHub repository. You can please follow these instructions. And then I'm changing the directory to sample Docker. And then I'm applying a Maven based clean build package. Okay, so you don't need to Maven also download in case. So this will be automatically supported. This will clean and build the package for you. Then you can switch to the Docker and you can create a Docker's tag. So here, this is the instruction which you need to follow. This is available here in the readme file. Build it sample docker 1.0. I'm creating that tag locally in the Docker's architecture. You have seen in the center box, right? That will store it in locally, and then I apply docker run, which is run it in the background. That is called daemon, and name of that is my image, and I'm exposing my Tomcat port 8080 to outside world to access it. What is the name of my image? Sample docker 1.0. Likewise 1.1, 1.2, like you can keep changing based on your needs. Then I am testing that application using either CURL or using HTTP on the browser. Whatever the, say if my Docker image is good, my application started running as a container, everything good, that means it is working as expected. Then what I'm doing is I'm stopping my container, okay, whatever the image which I created. So my image I'm specified because this is the name, and then I'm tagging locally tag sample docker 1.0 to, this is the name which I'm having, like this I'm creating, and then I use Docker login. It asks username password, I will provide, and then I push this image to the repository that is called the public registry, which is supported by the Docker. It is a commonly usable, a registry, whoever wanted. And then I can see that the hosted registry image is available or not. Yes, I can see that in the, you can also try to do it. If it is a public view, yes, it is available. If it is a private view, only who created, pushed that image, the same person can see it. Prerequisites, as I said, these are all required. So Docker desktop, install it on Windows or Linux, whichever operating system you are using it, and internet connected, because it is going to download the images from the internet. And this is used here, I'm using Java based application. That's why intended audience could be middle level experience, low level experience, or architects, whoever is willing to do it. So these are the links. So Docker, if you want to study about Docker compose file, Docker file, definitely you can visit this site. And I was talking about the public registry. This is the public registry, hub.docker.com. You can go ahead and create your account, and then you can start pushing your images, public or private view. And here is the source code available, which with all the instructions. Please try to do it. So that's all about Docker service. I hope you enjoy it. Like it, share it, subscribe it. I come up with a new video. Thank you.